my friends. Deepak here, and we are continuing our conversations with influencers and a motley group of sages, scientists, geniuses, and psychotics. So I'm currently reading this book, which I found extraordinarily engaging, The Disordered Cosmos, whatever you want to call it, A Journey into Dark Matter, Spacetime, and Dreams Deferred. And since my special guest is Chanda Prescod-Weinstein, and she has mathematical intuition, I also happened to read this recent article called The Secret Language of Reality. So I found the book very engaging and interesting. Thank you for being here, Chanda.
Yeah, thank you for having me.
So let's start a little bit from the beginning. Our audience is pretty sophisticated, and they've seen these conversations with many other scientists. At your suggestion, by the way, I read Lee Smolin's book also. We can talk about that later, but I think most important, our audience would like to know a little bit about you. Where did you grow up? What's your background ethnically, racially, and how did you get into physics?
Yes, I'm originally from East Los Angeles. So for people who know Los Angeles geography, specifically El Sereno. And I was primarily raised by my mom, who's from Barbados. So she's an immigrant to the United States. She came over a week before her 12th birthday, or her 13th birthday, basically. And my dad, who was also present in my life, is a white Ashkenazi Jew who was born in Los Angeles, but mostly grew up in Trinidad and England in the Caribbean community in London. So I grew up primarily in Los Angeles, but also spending time in Brooklyn with my mother's family there, and then also in London with my father's family there. So my upbringing was maybe unusual for a physicist. And my parents are both political organizers. Pretty much everybody in my family is a political organizer or a teacher. Those are the two family traditions. And so it's a little bit unusual that I got interested in science and stuck with it. But also maybe the fact that I became a professor is not so unusual from a family of teachers. So I think that's the small, I guess you asked, yeah, go ahead.
What drew you to physics?
When I was 10, one of my teachers told my mother that I was very excited about the physical science stuff we'd been learning in class. And by that point, it was clear I loved doing math. And so my mom took me to see a matinee of the documentary about Stephen Hawking, A Brief History of Time, the Errol Morris documentary. And, I was 10, so I just wanted to be at home watching like cartoons. So I complained the whole way into the theater. I was like, why are we going to see a documentary? Those are for adults. And about halfway through the documentary, they were talking about how we didn't understand what happens at the center of a black hole. We didn't understand the singularity, and that this was a problem that Einstein hadn't worked out, and that they used math to try and work through these problems. And I think there was like a light bulb moment. As a working class kid, I was like, oh, so I have to have a job and I can get paid to do math all day. So why wouldn't I just want that job? And so I came out of the theater begging my mom for a copy of the book, and the rest is history, as they say.
Would you call yourself a cosmologist, a theoretical physicist, a mathematician, or all of the above?
I think I will go with all of the above. I've accepted that people are going to apply labels, and the minutiae of which one means which often goes over people's heads. Even in the physics community, sometimes these titles change. So sometimes people say I'm a theoretical astrophysicist. Sometimes they say I'm a theoretical particle physicist. I guess if I had to pick a title for myself, I would say I'm a theoretical physicist, and in the broad, classical sense.
So let me start with some of the conundrums that I am faced with as a non-scientist. I'm a physician by training and a neuroendocrinologist, so I do understand brain science. But the conundrums that surround the so-called particle, the standard model, are quite huge, I think. First of all, and correct me wherever I make a mistake.
Sure.
We don't know what caused the Big Bang, if it happened. Of course, all you guys think it did, but we don't know the cause. We don't know why it happened precisely when it happened. Why not before or after? We are a little species in 2 trillion galaxies with 700 sextillion stars, and now they say uncountable trillions of planets, possibly 60 billion habitable planets just in the Milky Way galaxy. So on this little grain of sand in all the beaches of the world is a species called Homo sapiens, with a brain that thinks there's a world out there that is totally objective. But yet we don't have any idea why the so-called inflation was so precise. Trillionth of a trillionth of a trillionth of a second, it triples in size and then suddenly slows down. There were no laws of physics, the Planck scale or Planck epoch. And the cosmological constant, the observed value, and the theoretical value is so far apart that it's almost ridiculous. And as you know, you're an expert, most of the universe is dark energy and dark matter. And if that dark matter is non-atomic, it possibly is unknowable. So is this whole thing just a great scientific fantasy?
No,
I think it's a beautiful story, but
it's a beautiful story, and it's a weird story. So weird is always relative, right? But I would say weird in the sense that it's almost something that you can't make it up, that the data kind of points in that direction. And I actually think dark energy, let's take that as an example. And that's what I came of age with that, the announcement that cosmic acceleration was occurring, that the speed that space-time was expanding at was actually increasing. That was announced right around the start of my senior year of high school. So I wrote about it in my college applications. And actually my application to Caltech, I cut out a piece of the Scientific American issue on cosmic acceleration and glued it into the application and said, I want to solve this problem. And that's what I worked on for my PhD ultimately. So this is something I don't think about it anymore, but I spent a lot of time with it, and I really came of age with it. And the interesting story that I heard about cosmic acceleration is that they were so far from going out and looking for that phenomenon that actually when some folks first looked at the data, the equation that we use is organized towards the opposite thought. And so the question that they were asking was, how much is that slowing down? Not how much is it speeding up? So they were looking for deceleration, because everything that we knew up until that point suggested that deceleration was a possibility. And so I won't name names, but I've heard some stories that someone looked at the data and was like, I don't understand, why is the sign in the opposite direction? And somebody said, well, it has to be because it's actually accelerating. And so that's what I mean in the you can't make it up, which is that people went into that with a really strong assumption. And there were two different teams that were working independently of each other and in competition with each other, looking at supernova, so exploding stars, and making these distance measurements. And they were both forced to come to this conclusion that actually it's accelerating, it's picking up speed, it's not slowing down. And so I really think, when you think about, oh, the universe, it's so fantastical, the story of cosmology is so fantastical, it can't possibly be true. I actually think that the takeaway you should be getting from it is like, wow, our universe is just really that fantastical. I don't need magic because science is like almost magical. I think that that's like another way of reading it.
Yeah, well, I was reading Lee Smolin's book that you suggested I read, and he talks about all kinds of realism, including magical realism, but he also talks about naive realism. Naive realism is the basis, I think, of all science, which says that the world exists independent of our experience of it. I don't know how you prove that, because you have to first have an experience to describe it. So, I'm not a fan of naive realism, nor am I a fan of what is called subject-object split, because the subject of experience is part of what's happening in the universe, and this thing here is an observation deck for the universe to look at itself through a human species. So what we call data is, or empirical facts, is a species-specific experience before you call it data. So is realism your take as well?
I think so.
You don't think that this data is dependent on the human brain and human observation, and
no.
Therefore you don't?
No, and so I will maybe give you a somewhat different and a dorkier answer than maybe other people will give you to this question. So I just came back a couple of weeks ago from the Star Trek convention. I'm that kind of like a Star Trek fan that I go to the convention every single year. I have a whole friend group. I'm part of Facebook groups. I've watched at least an episode a day every day for the last 3 weeks. So I think part of why I give that information is to say that I actually suspect that we are not alone in terms of cerebral sentient species of the kind that we perceive ourselves to be. And so I don't think it can be organized around us, because I think that we are a small fraction of what's out there, and the universe is too big and too exciting to just be centered on us. And so I think, in the scenario where I could be convinced that we were alone, I might find that more plausible. But I will say that actually, from my point of view, as someone of African descent, and who's very, very conscious of the ways in which certain thought traditions are pushed on people, and have been pushed on people against their wills, right? And in a colonial context, that I worry a lot about the way that post-Enlightenment sensibilities about exceptionalism can inform how we interpret the data and how we interpret our location in the universe. And so I think that our task is to be humble in relation to that. And for me, that humility means recognizing that we are a small piece of what's out there, and no less precious for it, but certainly a small piece of that.
But you do or do not agree that the human brain and the universe are correlated, and there are many kinds of brain, many kinds of species that have different experiences. An insect with 100 eyes, I don't know what that experience is, or snake navigating infrared, or a bat that knows the world as the echo of ultrasound. Why is that less legitimate than the human experience of the universe? It has to be an experience before you can construct a model out of it.
Yeah, so I actually don't know that I think that the human perspective is unique, right? So, I mean, I think when you say the brain and the universe are correlated, I would probably say I want to make that more specific, because I would say to you, our brains are part of the universe. Like, we are one part of the universe that's trying to understand the rest of the universe, right? So I think that's an important perspective. I actually do worry a lot about this tendency that, again, I think is very much a Western cultural orientation to place humanity above other living species.
I'm doing the opposite, Chanda, right?
Yeah.
The opposite. I'm saying that the construct that we have, which you very adequately and very beautifully in this book call a colonial remnant, and you very eloquently and poignantly even talk about your, if I may say so, rape, and how that influenced your thinking about the legacy we have, because, it's a made-up legacy with even the terms and the constructs are the languaging of it. totally excludes consciousness, without which there is no experience. And therefore, I would say that the human brain is one mode of observation for the universe to know itself, but then there are infinite other modes. And not only on our planet, but if you say that we are not the only sentient beings in the universe, then there are probably infinite experiences of the universe. But they are all based on consciousness. Otherwise, it doesn't make sense. And that's where the Eastern wisdom traditions come in. They say that there's a fundamental non-local awareness that experiences itself as sensations, images, feelings, and thoughts. And then we have a construct that we have created a whole universe and in a dreamscape in the human mind.
So I think the place where I would probably diverge from you. So certainly I agree with you that, the human experience is but one experience. I'm looking at my window and there are many trees out here, and I spend a lot of time watching the wildlife, like the birds. We had a hawk fly into our storm door a month ago, and it was a really stressful experience because I really felt for the bird and felt very protective of it, right? And it was very clear to me that this is like a conscious being. Like I feel like I have that kind of relationship with nature that I think can be kind of out of sync with the way that we are encouraged in mainstream American culture to relate to non-human life forms. But I think I also believe that we can mathematically, for example, construct universes where life never evolves. You slightly change one of the fundamental constants and it becomes difficult for life to evolve. And I think that universe would still be real, even if there was no one there to talk about it or observe it or perceive it. I don't think the perception creates the universe, although I do agree that the perception through one lens, like your perspective, my perspective, can be different. We've seen different parts of the universe through our different trajectories in life. And those are certainly pieces of information about the universe. But even if those pieces of information didn't exist, the universe would exist.
What about mathematics then? I'm sure you're the unreasonable effectiveness of mathematics, as Eugene Wigner called it. Where is mathematics born? In human consciousness, or does it exist there in the universe independent of us?
So I think this is a deep philosophical question that people will probably be debating until the end of time. I genuinely believe actually that that's a question that may never be fully settled, right? Because it's a little bit of a chicken or the egg question. But I think what we can say is that the tendency to articulate certain mathematical frameworks as universal usually leads us to limiting ourselves, right? And so one of the examples that I give in the book is in the Western tradition, Euclidean geometry was considered like the prime, this is the right way to do geometry. This is the right way to think about geometry. And it was actually a horrible system for understanding the movement of celestial objects in the sky. And there were mathematical traditions that came out of, for example, the Palikir in the Amazon in South America, where they didn't use straight lines as the basis for their geometry. They used curved lines as the basis for their geometry. And that was in part because there were lots of snakes in the area where they live. And so the snake became a fundamental geometric shape and object for them. So my takeaway from that is the key piece is developing self-consistent mathematical systems. And there are lots of different ways to do that. And so I think one of the articles that you read in New Scientist, where I have a monthly column, was talking about this idea of you change the coordinates, but the physics stays the same, right? So this is really an example of something along those lines where you can use a different geometric system to describe the same shape, but some systems are better suited for describing certain shapes. Like you want curved lines in a scenario where things have a lot of curvature to them. And in a scenario where you have lots of triangles, that's where you want your Euclidean geometry. Like that's a better place to describe them. So what I would say is that I think a lot of it comes down to logic. I don't know if I have, so if you ask me where the logic comes from, I don't know if I have an answer for that question. I think that goes back to people are going to be debating until the end of time what they think about that. But I do think it's about logic, and that we all have access to logic in one way or another. That no part of the world has cornered the market on that.
Again, logic is a species-specific interpretation of human experience using a human nervous system, and therefore it's not the be-all and end-all of our experience of existence.
Well,
we think we have reason, we have emotions, we have intuition, we have insight, we have imagination, we have creativity, we have access to higher consciousness. Reason plays a very important role, but it's not the only experience we have. Reason cannot explain to me why I have wonder or curiosity or joy or fall in love or have fears or existential dilemmas or the fear of death. It's not mathematical. I don't think so.
There are some people who would argue it's chemical, though, right? That eventually it can be
a human construct for our experience. We name the chemicals. You just say we named all these things. As a result of our Western inheritance, we gave names to experiences, and then we kind of reified them as atoms and molecules and particles and force fields, when in fact we were having a human experience.
So I would not agree that atoms are simply a human experience. I think atoms are real, and they exist beyond us.
Concepts. You don't think they're concepts?
I don't think that they're concepts. I think that they are material, real phenomena, and that they are phenomena that exist and would occur with or without us, and that they are phenomena that we're comprised of,
okay.
Right?
I won't go in this direction because
Sure.
we disagree. But, in the Eastern philosophical systems, there's a very important statement. If you can see it, touch it, taste it, smell it, conceptualize it, imagine it, or think about it, it's not real. The only thing that's real is the invisible, which is non-conceptualizable, which in your concept, your mathematical construct, you might call it, what do you call it? The quantum field, which is brimming with randomly, according to the uncertainty principles, and somehow ends up creating the universe.
So I would say, even though the uncertainty principle and quantum mechanics in general introduce uncertainty and probability, there are still rules that are being followed, right? So we still have equations that are guiding how that probability evolves in time, okay. What possible states are probable, right? So I agree that it turns out that some phenomena are not deterministic, that some of them are probabilistic. And I actually think, as an example, if you can't make this up, people really resisted that interpretation of the science because it was so outside the realm of what humans had imagined and thought. So I think that that's a great example of the universe is always more fantastical than we think it is. And we don't need, anything beyond the science, because the science by itself is
You don't
exciting.
think it's more fantastical than we can think?
I think we can think because, so I hesitate to lecture you about anything involving neurology because then we're crossing into your territory. But one of the interesting things about math, just to bring it back to math a little bit, is that the equations that we solve to describe cosmology, to describe space-time, are very similar to the equations that are used in computational neuroscience to model how neurons fire, right? when I think about what's going on in my brain, what's going on in my body, I'm thinking about an electrical system in part that my body is maintaining, that my neural system is an electrical system. And we know that, in fact, neurons are exchanging ions, that's one of the ways that the information is transferred, right? So I think of humans as an incredibly elaborate, organic electrical system that has all of these needs. But when I think about consciousness, for me, that's consciousness, is this incredibly elaborate electrical system.
So you think the equations and the electricity came first, and consciousness emerged from that, rather than consciousness created the equations and then looked for electricity?
Yes, I absolutely think that consciousness has evolved out of this physical reality. And it's a phenomenal phenomenon, right? Like it's an incredible phenomenon. And I think we should be awed by it.
I am more than awed by it, but I think it is consciousness that conceives, constructs, governs, and becomes what we call the universe. And that consciousness is not an individual property. It's a non-local field of all possibilities, a superposition of possibilities that ultimately evolves into species-specific experiences. And those experiences humans codify as the objective world. That the human body and the human mind even is a projection of consciousness, because without consciousness, you won't have an equation. Where will the equation come from? The equation occurs, and then there's all this stuff with the, what do you call it, Gödel's theorem, theorems that are true but can't be proved. I mean, it's really, to me, it's more fantastical than even you are suggesting.
So, and obviously we disagree about this point, but I truly think that arises out of the materiality of us, that consciousness. So, for example, where did the equations come from? It is certainly true that the way that we describe the equations has social components to it, right? Because humans are involved, and once human consciousness is involved, human consciousness is a social phenomenon fundamentally, in how we interact and how we interact with the world.
Mind. Consciousness is not a social phenomenon. The mind is, certainly.
Okay, so we can agree on the mind, but I do think that the atoms that we are made of, the quarks and electrons that we are made of, as I talk about in the first chapter, they follow rules that exist whether or not we ever achieve consciousness, whether we ever become sentient, whether snakes ever evolved. Like the entire Earth could not be here. And in fact, in about 4.5 billion years, the Earth is probably going to be destroyed by our sun's death as it expands into a red giant and its final death throes. So we may or not survive more than a few billion more years, but I think that the universe will go on without us.
Are quarks an expression of an invisible, non-local field of possibilities?
I think that is one layaway that we might describe the framework that we call quantum field theory. And I think the comment that I will make about quantum field theory, which is maybe going to be really unsatisfying to everybody listening to this, is that I think that quantum field theory is a mathematical framework that allows us to approximate some physical connections. It allows us to capture mathematically things that are physically happening. Whether we have the right vocabulary for interpreting that into English or any other like non-mathematical spoken social language, I think is a separate question. But I think that one way that you can think about particles certainly is that they are excitations of a field that exists. But the question is, like, what does it mean for the field to exist? But to be clear, I think the field is there whether humans are there or not.
Well, that's what I'm saying. It's a field of consciousness, independent of humans. It's a field of consciousness that expresses itself in different species as different minds and different modes of observation, which require different biological apparatus, that the field itself is a field of consciousness that is actually creative. Now, let me give you a very simple story because I want to get the story out too. I've had a 25-year-old relationship with scientists, cosmologists, astrophysicists, philosophers, etc. So 20 years ago, and this is I'm sharing the story for the first time in public. I was at a TED conference, and before me, the speaker was Richard Dawkins. And, he's very condescending, Oxford accent and everything else. And he said, if you believe in consciousness or a higher being or whatever, non-local consciousness, you're probably very stupid or something like that. So, I went after him and I kind of deconstructed his talk. And I was for a time labeled as a fraud, etc., etc. Richard Dawkins ended up doing a movie called Enemies of Reason, where I was the main character, etc. Then a few years ago, Richard and I were debating in Mexico, and I quoted Freeman Dyson. I have all of his books here. And so, he has a book called Infinite in All Directions. And right in the end, he makes a statement where he says, every quantum experiment forces the atom to make a choice. And I just made that, I didn't make it up. I just was quoting his book. So Richard screamed at me and he said, Freeman Dyson couldn't have said that, number one. If he said, he was wrong, but he should sue you. So, for misrepresenting him. So I wrote to Freeman Dyson and I said, this is what Dawkins says and what do you have to say? And he sent an email to both of us, very gracious of him, and his very typical, humble way, actually. He said, 3 riddles have puzzled me all my life. The first riddle is, and he didn't use the word random. He said the unpredictable movement of particles. Unpredictable, not random. There's a difference. Okay, random is inherently random, and unpredictable means, to me, I can't predict it. It's like the uncertainty principle. The unpredictable movement of atoms or particles. Number 2, a universe fine-tuned for mind and consciousness. And number 3, our own consciousness. And he said, I don't have the answers to these riddles, but I think they're somehow connected. And that left me with a great sense of wonder and humility and awe at this great mind who didn't take just simple language and metaphors to explain reality. So anyway, the story goes on because then, I was another debate with Stephen Hawking's co-author, Leonard Malotnow, who wrote all his books, including The Grand Design. And, he basically, in this nationally televised debate, he ridiculed me and I called him up afterwards. I said, you know science, but I know consciousness. Why don't we take a walk in the park and you teach me science and I'll teach you consciousness? So he came to New York. We spent a great deal of time here. And then he said, why don't we write a book together? So we ended up writing this book, War of the Worldviews. And in the midst of writing the book, he gets a call from Stephen Hawking's daughter, who says, Dawkins called me and he said, you're working with Deepak Chopra. And if you continue to write this book, you're not invited to his 70th birthday party. So Leonard responded, he says, I have come to know Deepak. I disagree with him, but I'm going to write this book. And we've had a New York Times bestseller as a result of that. But what I'm saying is scientists have their own biases. They have their own prejudices, and they have their own programming, as you very elegantly say in this book as well. The science we have inherited is a Western colonial science.
So let me start by saying, without commenting on any of the individuals involved, because I don't want to get myself into any trouble.
Yeah, but I'm public about it.
Yeah, no, that's fine. It's your show. So I very earnestly believe that even when, and maybe especially when we have disagreements with people, that is when it's important to take seriously when someone is earnest. And I really am not a fan of the people who say, oh, well, that person has a religion or believes in a higher being or whatever, so they're an idiot. They don't understand science. They don't respect science. I, as a scientist, like, understand some of the panic that people have, like particularly having lived through the pandemic, people who are refusing to get vaccinated, or, you know, we're literally here in New Hampshire, we don't get nearly enough snow anymore. We're in a drought in New Hampshire, and I'm a Californian, right? One of the reasons I come to the East Coast is so we don't have these problems. And there are still people out there who don't believe in global warming. And so I understand on some level why people are very panicked about you know, people who have a different perspective on science and the workings of the world from them. But then I think that our task as scientists is to continuously come back and try and engage in conversation and teach. Because that is, at the end of the day, it is if we have the specialty knowledge, part of our responsibility is getting that specialty knowledge out into the world, right? And so I think approaching and labeling people and you know, saying this person is enemy number one, or if you're seen talking to them, it means that you're not a serious scientist and all of that stuff. I don't think it serves. And you know, I don't think you really said anything about race as a factor in this, but I do actually think that there is an element of it that is racialized because people from non-European heritages, or specifically like basically European and Christian heritages, right?
Or white.
Yeah, but specifically people who are not, both parents are white. We have cultural traditions and we have cultural perspectives that we are bringing to the table. And I'm very aware of that as a Black woman. I'm very aware of, for example, the ancestral traditions that my family has maintained. And as part of how my family that came to the Americas through enslavement, through the Middle Passage, that's the one piece of Africa that they were able to hold on to is some of the religious traditions. And that means that so I'm in my home office, that out in my dining room, I have an altar to my ancestors. I don't believe in the supernatural the way that my mother does, but nonetheless, I talk to my ancestors because it's part of my tradition.
Right now, you can't speak without your ancestors. You can't move your hand. Every gene in your body, every movement is dependent on your ancestors.
Absolutely. So absolutely. I feel that truly I carry my ancestors with me physically within my genetic code. That's a great way of putting it. So I don't think it's particularly productive to approach science the way that a lot of public scientists have been approaching it. Particularly, you know, just to take the US and the Black experience in the US as a particular example. And for a really long time, over half of Black America has attended church. So if your opening salvo is
worshiping a white god,
maybe for some of them,
what they perceive,
certainly for some of them, right?
I've been to gospel churches and I said, you guys, was Jesus white or was he Black or was he brown? And they can't answer the question.
So it depends on what church you go to, right? Everybody has, but regardless of whether, you know, they're Muslim, which, you know, a lot of the enslaved people who came over were Muslims who were forcibly, who had Christianity forced on them. When you start by saying that if you believe that stuff, right, air quotes, that we can't talk science, you've basically just said to a whole population, science is not for you. And that is not how you actually, like, let's say we have a genuine disagreement. There's no way you're hearing what I have to say about it if I've already told you that I don't respect you, right?
Yeah. This is a beautiful book, Journey into Dark Matter, Spacetime and Dreams Deferred. It would take us a long time to go through the book, but I just want to say that it's more than science. The book is a story of culture, of the bias against women, against violence against women. You're a strong believer right now and a proponent of women empowerment. And this is a statement of not just science, it's a statement of the condition of the world we are in and how we got here. What was your reason for writing this book?
So the book that I published was not the book that I originally planned to write, which I'm sure having written several books, you've had the experience of the book tells you about itself as you're working on it, right? And so originally, the way that this got started is that I was blogging. I'm desperate to draw attention to problems with racism and sexism in the physics and astronomy communities. And so I was just blogging about it and I was tweeting about it. And at some point, an agent approached me and said, have you thought about writing a book? And I wrote to her and said, if you want me to write a memoir, it's not going to happen. So we shouldn't even have a conversation if what you want is a memoir. And I think there is this kind of culture of wanting people from minority backgrounds who have reached a certain level of achievement to write some tragic memoir of tragedy and triumph. And this is how I overcame. And now it's all rainbows and my life is perfect and I have achieved. And I wasn't at that point in my life. I was still a postdoc. I didn't have a faculty position. I wasn't a professor yet. And the other piece was that I also felt like I was too young. I didn't feel like I had like a message for the world in that way to sum up my life and tell people what I thought about how life works or anything like that. So then she said, no, we can still talk. And so I said, so what kind of book do you think I could write? And she said, well, you have this body of work, but it's only online right now. And there's a whole audience that could be introduced to it through reading your book. And so the original idea was that I was going to take the essays I had been writing about the problems in science and I would adapt them for the book. When I actually sat down to write, I found that I wanted to go back to my childhood dream of writing my own A Brief History of Time. And I found that I couldn't make the case for why anybody should care about what was broken in science without telling people what was amazing about it. And so my hope is that the way that the book works is it opens with just the science, right? It's really focused on particles and space-time and cosmic acceleration. And by the end of the book, I'm talking about Black feminism. I'm talking about fighting colonialism, fighting white supremacy. And I'm talking about how we're going to do that in science and the importance of doing that in science. And my hope is that the ending is compelling because you got excited with me at the beginning. That's the way the book is supposed to work anyway.
I found the entire book compelling. It reminded me also that we are all products in a way of history, all of us. When I was an intern, this is 1970, probably before you were born.
Yes.
My wife got pregnant and chief of medicine called me. He said, there's something very drastically wrong with your wife's blood assays. I said, what? She has thalassemia. I said, she would be dead if she had thalassemia. He said, come and look at the slides. So I went and looked at the slides, and sure enough, the cells looked like this Mediterranean anemia, which is usually fatal. And she was pregnant, and she was 21, and she was healthy. So at that time, there was no Google, nothing like that, and no way. So I went to the New York library, spent 2 days, and found that there was a belt of thalassemia minor and thalassemia along the exact route that the armies of Alexander the Great took, we call him, Alexander the Conqueror, the rapist, they took from Macedonia all the way to India. So somewhere along that line, 2,500 years ago, or whatever, 323 BC, there was probably a rape. And there she was, my wife, the product of that history 2,500 years ago. So, I am very humbled by the fact that our existence is a mystery, and science is the best attempt to solve that mystery. But I think the mystery is unsolvable. Why do we exist? Why did the Big Bang occur? Why did it occur when it occurred? Why was cosmic inflation so precise, if it is the explanation? Are there multiverses? Are there infinite verses, as Caltech professor Sean Carroll says? So, I mean, you look at this landscape, it's very, very, very riddled with contradictions and arguments, which is good for science advances through that, of course.
I guess what I will say, and actually I should say Sean has moved to Johns Hopkins University.
Oh, he has.
Caltech lost him.
I interviewed him recently. He's very eloquent.
Sean is fantastic. He wrote a general relativity textbook that came out my first year of graduate school. That was very influential. In fact, I read it so many times it fell apart. I had to buy a second copy. And it's a beautiful book, in addition to all of his books for general audiences. But I think I'm just going to give a highly materialist answer to that, and just say, like, if these are questions that are difficult or even impossible to solve, that's great, because it means people like me will continue to have jobs and things to do with our time.
Good for you. Well, I think in the end, I have surrendered to mystery, and I feel at peace. But this was an amazing conversation. I encourage everyone to look for this book, The Disordered Cosmos, A Journey into Dark Matter, Space-Time and Dreams Deferred. You'll be surprised. It's very eloquent. It's very poignant in places. It's very human, and it is good science as well. Thank you, Chanda.
Thank you so much for having me.
Thank you.